Okay, we're going to start 8.1 notes today. Greatest common factor notes. I'm going to go ahead and put 8.1 in the front of it. And if you'll recall, a factor of a given number is every number that divides evenly into that number. So if we want to list all of the factors of 24, we would I always start with 1. 1 and 24. 2 and 12. 3 and 8. 4 and 6. Okay, and I kind of go in numerical order because once I get to 4 and 6, the only other number between 4 and 6 is 5, so I know I'm done, and then I would start coming back up on this side. So those are all the factors of 24. The greatest common factor of a 2 or more number is the largest number that divides evenly, or that divides each number evenly. Okay. To find the greatest common factor of 2 or more terms, list all of the factors of each term and identify which factor is the greatest one they all have in common. Okay, I'm going to move my page down. Okay, and it says find the greatest common factors of the given integers. I like to use the ladder method. Instead of listing the factors for each one, I'm gonna draw a ladder here, and I'm gonna look at 24 and 15, and I'm gonna start with 2. Does 2 go into both of these? No. So then I move up to my next number, 3. Does 3 go into both of these? And yes, it does. So I'm going to write 3 on the outside of my ladder, and I'm going to divide that out. So I got 8, and I've got 5. Well, then I want to see, does 3 go in again? No, it doesn't. So then I want to go to my next prime number, which is 5. Can I divide both of these by 5? And the answer is no. So I can't go any further than 5 because then I know that any number greater than 5 is not going to go in there. So this means that 3 is my greatest common factor. Okay, let's try this with 16 and 48. I'm going to draw a ladder, and I'm going to start with 2. Yes, 2 goes into 16 and 48. Well, I'm going to divide that out. I get 8 and 24. Then I see, does 2 go into that again? Yes, it does. So then I get 4 and 12 left over. Does 2 go into 4 and 12? Yes. I'm going to keep dividing by 2, and I get 2 and 3. Nope, 2 and 6. Okay, can I divide by 2 again? Yes. Then I get 1 and 3. So anytime I get down to 1, that means I'm done. And these are the factors on this side of the ladder. Now, to get the greatest common factor, I'm going to multiply those together. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So the greatest common factor between 16 and 48 is 16. Now, find the greatest common factor of a given variable term. So x to the 5th and x to the 3rd. Really what we want to do is we want to look at the smallest exponent in common. The smallest exponent in common. Okay, so that means that out of x to the 5th and x to the 3rd, x to the 3rd is the smallest. That's the greatest common factor. Okay, so this is going to be x to the 3rd. Why? Well, I have 1, 2, 3, 4, 5 x's for x to the 5th, and I have 1, 2, 3 x's in x to the 3rd. Well, how many x's do they have in common? Well, this one has 3 x's, and this one has 3 x's. That's the most they have in common. So it ends up being the smallest exponent. So for example, a squared and a to the fourth, again I'm going to look for the smallest exponent, and it's going to be a to the second. So that means they are going to have a to the second in common. And again, a to the second is a times a, and a to the fourth is a times a times a. So that means that this has two a's and this has two a's. So a squared is going to be the greatest common factor. Okay, I'm going to need to move my screen down. Okay, find the greatest common factor of the given monomials. So if I take, excuse me, 16 and 24, so I'm going to take my coefficients and I'm going to use my ladder method. I'm going to divide by 2. I get 8 and 12. I'm going to divide by 2 again. And I'm going to get 4 and 6, and I'm going to divide by 2 again, and I get 2 and 3, and I'm keep dividing by 2 until I can't divide by that number any further. Okay, well I'm not going to be able to divide by 2, and 3 doesn't go into both of them. 3 would have been my next prime number. So that means that these are my factors, and I'm going to multiply them together. So 2 times 2 times 2, and that gives me 8. So coefficient-wise, they have an 8 in common. Now, if I look at a squared and a third, remember we're looking at the smallest exponent. So the smallest exponent is a squared. So they have a times a, and this has a times a times a. So the biggest number of a's they have in common is 2. So our greatest common factor becomes a8 squared. 8a squared. Okay, number 1. I'm going to go ahead and do my ladder method on the coefficients. So they can't both be divisible by 2, so my next prime number is 3. And I can divide by 3. I get 5 left over, and I get 14 left over. I can't divide by 3 anymore, and I can't divide both of them by 5, so that means I'm done. Can't go above 5. So my coefficient, the greatest common factor, is going to be 3. And again, I want to look at my smallest exponent. So p to the fifth is my smallest exponent, and that's going to be the power. 3p to the fifth is going to be the greatest common factor. Number 2, I'm going to use my ladder method again. I can see they're both divisible by 2, so I'm going to divide out of 2, and I get 6 and 9. Well, I can't divide 9 by 2, but I can divide 6 and 9 by 3, so I'm going to move up my prime numbers, and I get 2 and 3. And I can't divide these by 3 anymore, so that means I'm done since I have a number smaller than 3. So I'm going to multiply those back together. 2 times 3, that gives me 6. Now I want to look at my r's, and I want to look at the smallest exponent, and it looks like I've got a 2. So the common r is going to be r squared. And then I want to look at my t's, and I want the smallest exponent, and this one's going to be my smallest exponent because it's actually to the first power. So they at least have one t in common. So 3, 6r squared, t becomes my greatest common factor. Number 3, I'm going to go ahead and use my ladder method, and I'm going to check 2, can't divide by 2, and I can't divide both of them by 3, but I can divide both of them by 5, and I get negative 15 and 5, and I can divide by 5 again, and I get negative 3 and 1. And like I said, when you get down to 1, you're done. So I'm going to multiply these back together. So my coefficient, greatest common factor, is going to be 25. And then I want to compare the r's again. And r to the second is my smallest exponent, so they at least have two r's in common. They don't both have s's, so that means they do not have an s in common. And then I want to compare my t's. And again, I have a t to the first power, so they at least have one t in common. So my greatest common factor is 25 r squared t. Okay, number 4, I'm use my ladder method again, and yes, it works on more than 2 terms. They can all be divided by 3. And I get 1 left, 6 left, and 11 left. So I'm down to 1, so that means I'm done. So I know they have a coefficient of 3 in common. Then I'm going to compare my p's. I have p squared, and p. So p is my smallest exponent of p, so they're going to have at least one p in common. And I've got q to the third, q to the second, q to the fourth. So q to the second is going to be the greatest common factor. They at least have two q's together. So my greatest common factor is 3p q to the second. Okay, let's go to the next page. Okay, so now that we've found the greatest common factor, we're going to factor it out as a series of polynomials. Okay, so in the example, I have 16a squared minus 24a, and again, I'm going to use my ladder method, and I see they're both even, so I'm going to start dividing by 2, and I get 8 minus, and then I get 12. They're still even, so I can still divide by 2, and I get 4 and 6, and they're still even, and I can divide by 2, and I get 2 and 3. And now I am done because I can't divide by 2 anymore, and then I can't divide by 3. So my factor, coefficient-wise, I'm going to multiply 2 times 2 times 2, and that's going to give me 8. Looking at my variables, my smallest exponent is the a, so I'm going to have 8a. So now we're going to factor that out. So I'm going to have 8a on the outside. So when we're factoring out a monomial, we're doing the opposite of the distributive property. You can see that here. Factoring is the opposite of distributing, which means instead of multiplying it through, I've got to divide it out. And I want you to pay particular attention to right here at these factors that we have left over at the end. These become our leftover coefficients. Okay, that's going to be helpful when we do our binomial. Okay, so if I divide out 8a, well, I have a coefficient of 2 left over. Here's my coefficient of 2 left over. And then if I'm dividing a squared by a, I subtract the exponents and I get an a left. So the first term in my binomial becomes 2a. Then I have a 3 left over. So I get minus 3, and then I divide out the a's by subtracting the exponents. A divided by a gives me a to the 0th, which equals 1, and negative 3 times 1 is 3. So this becomes my factored binomial. I get 8a, the greatest common factor, and I divide that out, and I get 2a minus 3 left over. Okay? The next example, they're all even, so I can divide by a 2, and I get 3, negative 9, and negative 6 left over. And then I can divide all of those by 3, and I get 1, negative 3, and negative 2. Okay, so I'm going to be dividing out a 6. And then I'm going to look at my exponents. I have a 2, a 1, and a 5. So that means the 1 is going to be the one they have in common. So they have at least one y in common. And so 6y is going to come out on the outside. That's their greatest common factor. And again, the numbers that I have at the bottom are going to be my leftover coefficients. So that's, I already know what they're divided out to. So I could put those in my terms. I can have 1, negative 3, and negative 2 filled in for my coefficients. And then I got to do my y's. So y squared divided by y gives me a y. Y divided by y, again, cancels out and leaves me a 1. So 3 times 1 is 3. And y to the 5th divided by y gives me y to the 4th. So here's my completed factored problem. Okay, again, factoring is the opposite of distributing. So I'm going to factor out 9p squared minus 12p. And again, I'm going to use my ladder method. And I see I can divide both of these by 3. So I get 3 left minus 4. And I can't divide by 3 any further. So 3 is going to be one of my greatest common factor number-wise, and then I want to compare my p's, and it looks like I've got a p in common, the smallest exponent. I'm going to put my parentheses. So now I'm going to divide 9p squared by 3p, and I already have those coefficients over here at the bottom. So I have 3 left over, and p squared divided by p gives me a p, and then I have minus 4 because p divided by p equals 1. So here's my factored binomial.